Hello everyone, my name is TNS Sharashma from CSIT second year and my roll number is 21951A3323 and the topic I am going to present today is 10 optimizations on linear search. This is an ATT Tech Talk presentation. In order to know what are the 10 optimizations of a linear search, you need to know the meaning of a linear optimization is. Optimization, also known as a mathematical programming, collection of mathematical principles and methods used for solving quantitative problems in many disciplines, including physics, biology, engineering, economics, and business. The subject grew from realization that quantitative problems in manifestly different disciplines having important mathematical elements in common. Because of this commonality, many problems can be formulated and solved by using the unfit sets of ideas and methods that can make up the field of optimization. So, optimization is also known as a mathematical programming or the collection of mathematical principles. We all know a linear search is a process of searching an element in a given set of array, whether it is not arranged or arranged in an order. So first optimization of a linear search is don't optimize the code that is fast enough. The first optimization comes from deciding to optimize time and not the algorithm itself. First, ask whether the code is fast enough already. If it is, you can optimize your time by not optimizing this code at all. This requires a definition of fastest enough. Suppose 200 meters minutes and under it's fast enough. Anything that takes 200 minutes or above is perceived to be instantaneous by the human brain. Therefore, any algorithm that can complete the task in less than 200 minutes is usually good enough for the interactive software. Donald Trump famously wrote that the premature optimization is the root of all evil. Optimized solutions are usually more complex than the solution they replace. Therefore, your risk of introduction of bugs into the system. A bird in a hand is worth two in a bush. Why adding complexity when you don't have to do? My biggest concern with the premature optimization is to distraction from the other, more importantly, work. Your time is precious and infinite. Time spent on premature optimization is the time that could be spent on most important work. So the first optimization is if the code is less than 200 minutes, don't optimize the code. That is fast enough. Use SIMD instructions. Most, most modern CPUs have SIMD, single instruction multiple data instruction, that let you to repeat the same operation over a large swath of memory. They are able to do this very quickly because they benefit more efficient memory access and parallel operations. According to the benchmark, a 2.67 GHz core i7 saw a 7 to 8x improvement by using single instruction and multiple data instruction where n equal to 100,000. If the amount of data exceeded, the CPU cache size also increases. The benefit of drop to the 3.x with SIMD. Small because of 45 million elements or about 180 megabyte. Work in parallel. Even if n is a larger than the small quantity, you can keep within your 200 minutes time budget by using a multiple CPUs. Each CPU core can search a share of the time. With 4 CPUs, 4 small becomes foreign and nearly 200 million items can be searched. When I was in a college, I studied of parallel programming was a hypothetical because we didn't have any access to the computer with more than one CPU. In fact, I didn't think I would ever be lucky enough to access a machine with such a fantastic architecture. Boy, was wrong. Now I have a phone with 8 CPU cores, one of which I believe is dedicated exclusively to crushing candy. Parallel processing is now the normal, not the exception. Code should be written to take advantage of it. So the third point is work in parallel. The fourth optimization is hide the calculations in another function. The search of the maximum value can be hidden in other function. For example, earlier in the process, the data is loaded into memory. Why not have the code also track the maximum value as it iterates through the data? If the data is being loaded from the disk, the time spent waiting for the input or output will dominate, and the additional comparison will be essential free. If the data is being read from a text file, the work to convert ASCII digit to a 32-bit integer is considerably more than tracking the larger value seems so far. Adding maximum value track would be error in the noise of any benchmarks. Therefore, it is essential free. You must point out that this violates the SOC separation of the concern principle. The method that loads data from the file should just load data from a file, nothing else. Having it also track the maximum value along the way adds a complexity. True, but we have already decided that the adding complexity is worth the benefit. The fifth one is maintenance the maximum along the way. What is the maximum value cannot be tracked as a part of loading the dataset. Perhaps you don't have a control that the method that loads the data. If you are using an off-the-shelf JSON, that is Java script object notation, adding the ability to track the maximum value would be very difficult. Perhaps the data is modified after being loaded, or it is generated in a place. In such situations, I would ask why the data structure holds the data isn't doing the tracking itself. If the data is only added, never removed or changed, the data instruction can easily be tracked the largest value seen so far. The need of a linear search has been avoided together. If the items are being removed and changed, more sophisticated data structures are required. A heap makes the high value access in 0 of 1 time. The data can be kept in the original order, but in a heap or other index on the side, you will. You will then always have a faster access to the highest value. Through you will suffer from additional overhead maintenance the indexes. Sixth one. Hide long calculations from the user. May the process cannot be made any faster, but the delay can be hidden from the user. One good place to hide the calculation is when waiting for the user input. No need the entire processing power of the computer to ask, "Are you sure?" and then wait for the response. Instead, you can use the time to perform calculations and not one will be wiser. One video game console manufacturer requires game to have some kind of user's interaction with a few seconds of starting. Sadly, mostly games need more than that to load and initialize. To meet the vendor requirements, most games first load and display a title screen, then ask the user to click a button to start the game. What users don't realize is that while they are sitting in ABE or amazing title screen, the game is finishing its preparations. It's one of the optimization. So the sixth optimization would be hide long calculations from the user. Use a good enough value instead. Is the maximum value specially needed or it is estimated good enough? Everything, perhaps the calculations can be avoided entirely. Often an estimated is enough, and there are many creative ways to calculate one. Perhaps the maximum value from the previous data set is good enough. Perhaps the maximum value is being used to pull, locate memory or the other resources. Does this process really need to be fine-tuned every time the process runs? Might it be sufficient to adjust the allocation only occasionally, perhaps in the response to rescue monitoring or the performance statistics? If you're dealing with a small amount of data, using the earlier definition of small, perhaps reallocating resources is overkill. If you are dealing with a large amount of data, perhaps pre-allocating resources are unsustainable and need to be re-engined before it becomes dangerous. The eighth one, seek inspiration from the upstream process. Sometimes we need to get a different perspective by examining the inputs, where the data comes from. I once observed a situation where a developer was complaining that an operation was very low. His solution was to demand a faster machine. The Sidon, who investigated the issue and found that the code was downloading millions of data points from the database one continent. The network between the two hosts was very low. A faster computer would not improve the performance. The solution is, however, was not to build a faster network either. Instead, we moved the calculations to be closer to the data rather than downloading the data and to do the everything calculations. The Simon recommended changing the SQL query to perform the calculations at the database server instead of downloading millions of data points. Now we are downloading a single answer. The solution seemed obvious but allocated the otherwise smart developer. How did it happen? Originally, the data was downloaded because it was processed and manipulated many different ways for many different purposes. Over time, however, these other purposes was eliminated until only one purpose is remained. In this case, the issue was not calculating the maximum value, but simply counting the number of data points, which SQL is very good at doing for you. The ninth one, seek inspiration from the downstream. Another solution is to take a look at what is done with the data later in the process. Does some or the other process depth sort the data? If so, the maximum value does not need to be calculated. You can just simply sort the data in the process and take the last value. You wouldn't know the process possible unless you took the time to talk with the people and understand the end-to-end flow of the system. Once I was on a project where the data flowed through the five different stages, controlled by the different streams. Each stage took the original data and sorted it. The data did not change between stages, but each team made a private copy of the entire dataset so they could sort it. Because they haven't looked outside the slots, they didn't realize that how much waste effort this entangled. By sorting the data earlier in the flow, the entire process becomes much faster and sorted faster. 10th one. The 10th optimization is question the question. When preparing the column, I walked around the New York office of a Stackflow.com and asked my coworker if they have ever been in a situation where calculating the maximum value was a bottleneck worth optimization. The answer I got was resounding. The number of developers point out that the calculation of the max is usually sometimes done infrequently, often once per a program. Optimization effort should be spent on a task to do many items. A developer with a statistical background stated that the max is useless. For the top dataset, it is an outer and should be ignored. What are the useful to him at the top n items which are present an entirely different algorithm challenge? Another developer point out that anyone dealing with large amount of data usually stores it in a database, and database can find the maximum value very effectively. In fact, he assigned and maintaining such data in a homogeneous system is a waste of effort at being and negligent at worst. Thinking you can maintain a large data set safely with a homegrown database in Hubs. Finally, the conclusion. Find another question. This brings me to the final point. Maybe the interview question posted at being of the this column should be retained. It might be a good logic problem or being a programmer, but it is not a good question to use while interviewing system administration because it is not realistic solution. A better question would be asked job candidates to describe a situation where they optimize an algorithm. You can listen to the story of science of operational brilliance. I would like to know the candidate determined ahead of time what would consider a good enough. Did they talk about stakeholders to determine whether the improvement was needed, how much improvement was needed, and how much would move if the optimization was achieved? Did they determine how much time or money spent were worth spending? Optimization that required an infinity budget are not really useful as one would think. Thank you so much.